All right, continuing our discussion on generalized linear models, this foundational paper. I'll include the link to this paper and the playlist that I'm making for this paper in the description of this video. In this video, we're going to be discussing this equation right here, which is that the first derivative of the log likelihood equals alpha of phi times z minus the first derivative of g of theta. Okay, so we're just going to show this this relationship right here in this video. Okay, so let's go to our blackboard. I've written the density function here, and then the first two equations that we've already shown in previous videos. Okay, so this is what we want to show right now. And it's actually pretty straightforward. What we need to do is basically write the log likelihood and then find the first derivative of it. So let's go ahead and do that. So capital L, remember, stands for the log likelihood. So log of our density function. Okay. And so our density function, so let me go ahead and write the first derivative of log. Our density function is this exponential family of distributions. So alpha of phi times z theta minus g of theta plus h of z. Okay, be really careful with your parentheses here. Plus beta of phi and z. Okay, and then I need to close my parentheses for the expected, or the exponential, and then close my parentheses for the log. All right, so now I just need to find the first derivative of this. Well, actually, before I do that, I notice that I have log of an exponential. These will cancel because, remember, in statistics, when we write log, we mean natural log. So the log of an exponential, basically, they cancel each other out. Okay, so actually, let me write this one more time. Alpha of phi times z of theta minus g of theta plus h of z plus beta of phi and z. Okay, so I need to find the first derivative of this with regards to theta. All right, so let's go ahead and do that. This is basically a constant, so it will stay out. Right, when I take this first derivative, this piece basically gets pulled out front. And then I have the derivative of z times theta, right? So this is basically a constant times the variable, which when you take that first derivative, you'll just get the constant. And then we need to take the first derivative of this function of g. Okay, and then I need to take the first derivative of h of z. Now, h of z doesn't include theta, so basically this is just a constant, so the derivative will just be 0. Okay? Then same thing goes on back here. This is beta of phi and z, which does not include theta, so the derivative of it will just be 0. All right, so now it's just a matter of just changing the notation a little bit because they're writing this using prime notation. Since g is only a function of theta and nothing else, we don't need to write the partial derivative type function or a notation. We can just write the prime to indicate that we need to take the first derivative with regards to theta. Okay, and that's it for showing that the first derivative of the log likelihood equals this jazz over here.